In this recording, we're going to learn how to convert between equations in rectangular form and those in polar form. So we're going to do two examples. We'll go one in each direction. First thing I'd like you to do after you write down the problem is to write down the tools we have over in this box here. So these are our formulas that we have that relate rectangular, in other words, the x and y, and polar, the r and the theta. So hopefully you got time to write those down, paused and wrote down our formulas. So when we have an equation like this, x equals 3, and we want to get polar involved, so we want something with with r's and thetas. So looking over here, I can convert x into r cosine theta. So let's go ahead and do that. Let's say in place of x, we're going to write r cosine theta equals 3. And then I simply want to get the r by itself, because we know our polar equations can either start out r equals a statement about the radius, or theta equals a statement about the angle. So we're going to divide both sides by cosine, right? And that could be the answer right there. Or if you remember, 1 over cosine is equivalent to the secant. So we could also write it as r equals 3 times the secant of theta. That'd be another form of that equation. The second equation we're going to convert is this. We're going to convert a polar equation, r equals 4 times the sine of theta, into rectangular form. So take a moment to write that down. Okay, hopefully you did so. And again, we have the same set of tools available to us. So looking for something to do with r, and I've got this. R squared would be more promising. I'd rather not deal with this square root. So here's a nifty little technique we're going to try here. We're going to multiply both sides by r. Let's make a little note about what we're doing here. I'm going to multiply both sides by r, so we've got r squared equals 4 r sine theta. All right, so that's pretty cool. Let's do something else with this. So I can see a couple things that could maybe get me into the x and y world. I've got this r sine theta, which I know I can replace with y. So on the right side, I can just simply say 4y. And again, r squared, I can say in terms of x squared and y squared. So on the left side, I can say x squared plus y squared. Now I'm in great shape here. So I can do a bunch of things with this. I think what I'm going to do at first is I'm going to write it this way. And you'll see some teachers, some texts will leave it just like. So sometimes you'll see the answer in this form. Well, we might be able to be a little more clever and get it to look like the circle that it is. This is really a circle. So let's see if we can get it into this form, the normal form of a circle, x squared plus y squared, or x minus h squared plus y minus k squared equals r squared. All right, so that's sort of a form of the circle where the center is at the point hk. So what we're going to do is complete the square for the variable y. So we'll leave our x squared alone. We're going to complete the square for the y. So if you remember, I want to take half the b value, if we're talking about a quadratic, the number in front of the linear form of the variable, half of that and square it. So we'll take -2, square it, so we get 4. So we're going to add to both sides, add a 4. Right, so I added 4 here and I added 4 there. Let's make a little note about what we just did. I'm going to complete the square in y here. This is now a perfect square trinomial, y minus 2, y minus 2. So I can write it as y minus 2 to the second power. And now I've got a nice equation in the form like we have here that I can now recognize the center and the radius. Thanks for watching.